Hi there. I'm Dr. Tim Siegler of the University of Washington, formerly of the University of Texas at Austin. I'd like to present some work we've recently published in Chem Nanomat on thallium bromide and thallium silver bromide nanocrystal synthesis. Perovskites have recently attracted a lot of attention as tandem photovoltaic absorbers on account of their tunable band gaps, their low temperature solution processing, and a wide range of other types of favorable optical and transport properties that make them very well suited for tandem applications. However, pairing these perovskites with CdTe, gallium arsenide, and other types of incumbent PV technologies requires perovskites that have low sub-1 eV band gaps, which is outside of the range of the composition space that's normally used in perovskite photovoltaics that have 1.2 eV band gap or higher. Recently, however, the Karuna Dasa group at the University of Stanford has developed a synthesis for a single crystal of cesium silver thallium bromide, a double halide perovskite which exhibits a direct 0.95 eV band gap. While this is very exciting and could provide an answer to this conundrum, the acute thallium toxicity of cesium silver thallium bromide means the traditional spin coating and solution processing of perovskite thin films isn't accessible to this material, as the thallium complexes would have to complex in this case with skin permeable solvent molecules like NMP, DMF, or DMSO, which is an unacceptable safety risk even in a lab setting. Therefore, the only way to proceed to try to make optoelectronic materials with this material system is to try to, in a sanitary environment, synthesize cesium silver thallium bromide nanocrystals and then engage in post-synthetic deposition using established optoelectronic nanocrystal methods. To try to synthesize these nanocrystals as a first step in this process, we took a metathesis reaction developed for cesium silver bismuth bromide by the Gamlin group and attempted to adapt it for this system, taking metal acetate precursors and injecting ready halogen donor trimethylsilyl bromide into our reaction mixture. While we did not yield the desired cesium silver thallium bromide nanocrystals we were looking for, we were able to, by taking the cesium and silver away, yield very nice, well-dispersed, shape and size uniform thallium bromide nanocrystals, and synthesize, for the first time anybody has done this, thallium silver bromide nanocrystals of dolomite type crystal structure by adding the silver back into the precursor solution. The optical properties of these materials show that they're not very well suited for direct photovoltaic applications, as they both have 3.1 eV band gaps. However, they're very high quality nanocrystals, with thallium bromide nanocrystals even forming extended FCC superlattice networks that have very strong small angle X-ray scattering diffraction patterns. Therefore, we hypothesize these materials might find good application as radiation detectors or radiation scintillating materials. Or even perhaps this reaction scheme could be used to create conformal shells onto luminescent perovskite cores, passivating traps, suppressing Auger recombination, and creating more effective luminescent perovskite heterostructures. This reaction, though, this result that we've achieved, does provide some insight into synthesis of cesium silver thallium bromide. We conclude that, and have observed that, our thallium-3 precursors yield very nice nanocrystal dispersions, very nice nanocrystal products, but they all incorporate monovalent thallium. And that, in fact, there is nothing that we can really do outside of changing our ligand composition that will prevent the reduction of this thallium-3+ on a very rapid timescale. Therefore, if cesium silver thallium bromide is going to be deployed in nanocrystal optoelectronics, alternative synthetic routes are going to have to be considered, as this is patently impossible to do in its current form. With that, I'd like to thank you for stopping by my virtual poster. Wish you all a great day and a great rest of the conference. Thank you.